Sine squared of t equals cosine. We're looking for all solutions. All solutions. Which means t could be an element of the reals. Now, the sine squared of t is equal to cosine. Normally we set these so that they're equal to 0 and then we factor. But here there's not going to be anything to factor because these trig functions are not the same. So when we see that that is true and we see a squared function, Pythagorean identity should come to mind. So sine squared of t plus the cosine squared of t equals 1. There's your Pythagorean identity. And since we have a sine squared here, we're going to solve this equation for sine squared by subtracting a negative, or subtracting a cosine squared of t from both sides. And what we end up with is that the sine squared of t is equal to 1 minus the cosine squared of t. And so this is what we'll take and we'll plug in there. 1 minus the cosine squared of t now is equal to the cosine of t. Now we can set it equal to 0. So 0 is equal to the cosine squared of t plus the cosine of t minus 1. If this were something we can factor, we could then factor into a product of two terms and then solve for when each one of those equals 0. But this one does not factor nicely. What we need to do is use the quadratic formula, which get the cosine of t will equal a negative b plus or minus the square root of b squared minus 4ac all over 2a. When this value right here is an element of the interval from -1 to 1. If this value is outside of the interval from -1 to 1, we will not get a solution. A 1 for A, a 1 for B, and a -1 for C, which means we get a -1 plus or minus the square root of 1 squared minus 4 times 1 times -1 all over 2 times 1. So we can simplify this further and say this is -1 plus or minus the square root. Now if this is 1 and this right here is a positive 4, we get 1 plus 4 divided by 2, which means that our cosine of t could either equal a -1 or a -1/2 plus the square root of 5 over 2, or the cosine of t could equal -1 minus the square root of 5 over 2, excuse me, -1/2. So let's look at this square root of 5 over 2. We know that the square root of 5 over 2 is less than the square root of 4 over 2, which is just equal to 2 over 2, which is equal to 1. If we added a -1/2 to both sides, then what we get is that the square root of 5 over 2 minus 1/2 is less than 1 minus 1/2, which is less than 1/2. Okay, and we also know that this square root of 5 over 2 is greater than 0. So we can subtract the 1/2 from that side as well. And we now know that it's greater than -1/2. So this value right here falls within the range that cosine values can output. So we can continue and find the solution for this one. For this one, I'm going to take a different approach to this one. I'm going to plot on the number line here a negative square root of 4 over 2, which is a negative 1. Now, this negative square root of 5 over 2 is more negative than square root of 4 over 2. So we'll just put it out here. Negative 5, square root of negative 5 over 2. And then we're going to add a negative 1/2 to it, which means we're going to go back this way more negative. So here is our negative 1/2 minus the square root of 5 over 2. Here's our negative 1. Here's our positive 1. And the cosine value can only give us values between negative 1 and 1. But this value right here is outside of that range. So we are not going to get any solutions for this equation because the cosine of t can never equal negative 1/2 minus the square root of 5 over 2. You can also see this by plugging this value into your calculator and getting a decimal approximation for it. At this point, we can say we are not going to get any solution from this side of the equation, and we can focus all our attention over here. So if this is true, then we know that the principal solution, t, is equal to the inverse cosine of negative 1/2 plus the square root of 5 over 2. This value right here is near a positive 1/2. So if we draw this on our unit circle and we mark where the x values are equal to somewhere near a positive 1/2, but not exactly a positive 1/2, we say that this is x is equal to a negative 1/2 plus the square root of 5 over 2. The principal solution gives us this one right here. Then we'll get a symmetric solution that hits this same line, and we can either write it as a positive solution or a negative solution. I'm going to choose the positive solution. So this would be our principal solution, the one that the inverse cosine gives us. Our symmetric solution, t is equal to 2 pi minus the inverse cosine of negative 1/2 plus the square root of 5 over 2 will give us this angle right here. Now, since we were asked for all solutions, we don't want just the two solutions that are between 0 and 2 pi. We want to add all the coterminal angles, which means if we add or subtract an angle from this point, if we add or subtract a period, go around one whole period, then we get to this point 2, and the cosine of t is equal to negative 1/2 plus the square root of 5 over 2. If we go around in the opposite direction, the same thing happens. That's another coterminal angle. So what we'll add here is some number k times the period, where k is going to be an integer. This means that if you take any integer value and multiply it by 2 pi and add that to the inverse cosine of negative 1/2 plus the square root of 5 over 2, we're getting coterminal angles, and we're getting more values in which the cosine of t is equal to negative 1/2 plus the square root of 5 over 2. And we'll do the same thing to the symmetric solution. So plus k times 2 pi. So these are our solutions. We can write this down. We only have two sets of solutions. We know from the original equation that the sine squared of t is equal to the cosine of t when t is equal to the inverse cosine of negative 1/2 plus the square root of 5 over 2 plus 2 pi k, and when t is equal to 2 pi minus the inverse cosine of negative 1/2 plus the square root of 5 over 2 plus 2 pi k, where k is an element of the integers. So this is our conclusion. Two sets of solutions, an infinite number of solutions. They can be generated by letting k be specific values. If you only wanted the values between 0 and 2 pi, you would let k equal 0, and both of these will be the two positive angles between 0 radians and 2 pi radians.